Hello, I'm Dr Roo, and this is the last of 3 parts of my review of GCSE level number theory. While we've now covered all of the theory, we address the practicalities of actually performing calculations with numbers by way of progressive examples. We start by removing negatives from the problem. We have learned that adding a negative is the same as subtracting the corresponding positive, and subtracting a negative is the same as adding the positive. We also know that multiplying and dividing a positive and a negative gives the negative the result of operating on positives, whereas multiplying and dividing 2 negatives gives exactly the same result as operating on the corresponding positives. Thus, in all cases, we can reduce problems with negatives to corresponding problems entirely expressed in terms of positive numbers, and so we here only concentrate on operations on positives, starting with long decimal numbers. We'll start with an easy one, 234 plus 3621. We use the fact that the numbers can be broken down into some number of thousands plus hundreds and tens and units, and that addition is associative and commutative, meaning that we can do the additions in any order that we want to. We write the numbers aligned vertically and work from the small end to the bigger end. So we have 234, 3621, and we're going to add them together. So we have 4 units and 1 unit, which makes 5 units, and we're going to add to that 3 tens and 2 tens, which is making 5 tens, 2 hundreds and 6 hundreds is 800, and then the 3,000, and we get the answer is 3,855. A more tricky one, we will do 954.23 plus 59.069. Once again, we write them in columns. That's 954.23 and 59.069, and you can see that I've been careful there to make sure that the decimal points are lined up. Now the first thing that we do is we fill in missing columns with zeros, which we can always do like that. So we work out 0 thousandths plus 9 thousandths is 9 thousandths, 3 hundredths plus 6 hundredths is 9 hundredths, 2 tenths plus 0 tenths is 2 tenths, and then we've got 4 units plus 9 units, which makes 13 units. So we write down the 3 like that, and then we note that there's an extra 10 that we need to carry into the tens column. We're given 5 tens plus 5 tens is 10 tens, plus the extra 1 is 11 tens. So again we write the 1 down and carry the next 1 across, and then we have the 9 and the 1, which makes for 10 hundreds, and the answer is 1013.299. For simple subtraction now, we will look at 956 minus 324. Again, we write them down in columns just like with additions. 9, 5, 6, 3, 2, 4, subtract. And now here we see that we've got 6 units less 4 units, which gives us 2 units. We've got 5 tens less 2 tens, leaves us with 3 tens, and 9 hundreds less 3 hundreds leaves us 6 hundreds. The answer 632. More tricky one. Let us do 324.23, take away 269.2. And again, you can see that we've lined the columns up with the decimal points under each other. Again, we'll fill in any missing columns. And now we do the subtraction. So we've got 3 hundredths minus no hundredths is 3 hundredths. We've got 2 tenths less 2 tenths, which leaves us with no tenths at all. Put the decimal point there. Now we want to do 4 units minus 9 units, but we can't have minus 5 units. What we do is we borrow a 10 from the next column. So we take 1 from there, so the 2 becomes 1. And we now have in 14 units, from which we take 9 units, which leaves 5 units. Now we're looking at 1 take away 6. Again, we can't have minus 5 as a digit in the final answer. Again, we borrow from the next field up, so that goes down to 2. And this now becomes 11 minus 6, which is of course 5. And finally we've got 2 minus 2, which leaves us with nothing, no hundreds, so we're left with the final answer 55.03. Simple multiplication now. Let's look at 3,234 multiplied by 4. Again, we write them one under each other with their columns all lined up, and now we're doing a multiplication. So what we're going to do is we're going to say 4 fours are 16, write the 6 down and carry 1 across into the tens column. 3 fours are 12, plus the 1 is 13. Again, we write the 3 and take the 1 across. 4 twos are 8, plus the 1 is 9. And 4 threes are 12 again, giving us the answer 12,936. Okay, we're going to do an intermediate level multiplication next. We're going to do 329 multiplied by 37. In order to do this, we're going to rely on the fact that multiplication is distributive over addition, so that we can work out the multiplications of the various bits and then add them together. Okay, so we first look at 7 times 9, and that is 63. So we write the 3 down, carry the 6. 7 twos is 14, plus the 6 is 20. So it's a 0 down, and we carry the 2s. And 3 sevens are 21, plus the 2 is 23. Now we're going to do 30 times 329. 30 of course is 3 times 10. And again, multiplication is commutative and associative. We can do things in whatever order we want. So we multiply by 10 first, and that's easy. It just means putting a 0 down and shifting everything else over to the left 1 place. So now we just have to worry about multiplying by 3. We have the 3 9s are 27, so we put the 7 down, carry the 2 across. 3 2s are 6, plus 2 is 8, and 3 3s are 9, like that. And then we add these results together. So we've got 3 in the units, 7, 11 there, and 9, 10, 11, and altogether 12. And the answer is 12,173. Now we'll do a more difficult multiplication. We will do 342.23 multiplied by 3.87. So 342.23, and we're multiplying by 3.87, like that. And again, you can see they're in columns with the decimal points lined up. And similar to what we did before, we first just look at the last digit here. 7 3s are 21, 7 2s are 14, plus the extra 2 is 16, 7 2s are 14, plus the extra 1 is 15, 7 4s are 28, plus the 1 is 29, and 7 3s are 21, plus the 2 is 23. We then put a 0 here for the fact that we're multiplying by a factor of 10. And then we look at 8 3s are 24, 8 2s are 16, plus 2 is 18, 8 2s are 16, plus 1 is 17, 8 4s are 32, plus 1 is 33, 8 3s are 24, plus 3 is 27. Now we're going to put 2 zeros down, and we're looking at multiplying now by this 3. 3 3s are 9, 3 2s are 6, 3 2s are 6, 3 4s are 12, and 3 3s are 9, plus the 1 gives us 10. Add this lot together, we have a 1, 10, we've got 17, 22 plus 1 is 23, and we've got 16, 22, 2 is 24, and we've got 6, 12, 13, 14, and we've got 2, 9, 11, and 1 is 12, 2 and 1 is 3, and finally the 1 there. And to work out where the decimal point goes now, what we have to do is we count the total number of digits on the right of the decimal in the problem, and that's how many digits we must count into the answer to work out where the decimal point goes. So it goes right there, and the final answer is 1324.4301. And a simple division now. We will do 936 divided by 3, and what we do here is we write it as 3 into 936 like this. And unlike all the other operations, with division we work from the biggest end of the number to the smallest rather than vice versa. So what we do is we say how many 3s are there in 9? Well, there are 3 because 3 3s are 9. 3s in 3 go 1, and 3s into 6 go twice. And so we get the answer, it's 312. A more difficult division, 17,382 divided by 12. Again, we write it as 12 into 17,382. And first we'll look at 12 into 1s, which is just ridiculous, they're not going to go. So we'll say look at 12 into 17s, and there's one of them. It's 1 12 fits inside 17. 1 12 is 12. So we now take these away to get a remainder of 5. So this 5 is the number of thousands that we've got, which hasn't been taken into account by the 1. Now we bring down the next digit here, and this then tells us that we've got to think about 12s into 53 hundreds. How many 12s are there in 53? In actual fact there are 4, because 4 12s are 48, And again, we do the same trick. We subtract these. So it's 5. And then we bring the next digit down, which is 8. We ask how many 12s are there in 58. Once again, the answer is 4. 4 12s are 48, which gives us the remaining number of 10. Again, we bring the 2 down. We ask how many 12s are there in 102. In actual fact, there are 8 of them. 8 12s being 96. And the difference there is 6. So there's 2 ways we can go from here. We can either say that the answer is 1448 plus an extra 6 12ths, 6 divided by 12, because that's the last part. So we just write it like that. And then we can see that the common denominator between 6 and 12 is 6. You can do this using the prime decomposition if you want to. 6 is 2 times 3, 12 is 2 times 2 times 3. So we can cancel out a 2 times 3 and we have 1 over 2. 6 is 1 times 6. 12 is 2 times 6. Alternatively, what we could have done is to add a decimal point in and put a 0 there, and then we can bring that 0 down to here, and then we ask how many 12s are there in 60. The answer in fact is 5, and we keep the decimal point in place there. 5 12s are in fact 60, so there's no remainder. So this is telling us that the answer is 1448.5, which is of course exactly the same as what we got before, because 5/10 is the same as 1/2. Okay, we move on to fractions now. A simple addition is 3 7s plus 5 7s. This is just very simply 8 7s, which is of course 1 and 1/7. 1 being 7 7ths and 1 7 being the extra. A slightly more tricky one. Let's look at 3/4 plus 4/5. Okay, so the difficulty now is that the denominators are different, and so the first thing that we must do is to apply a little trick to make them equal. And the trick is that we multiply the first one by 5 divided by 5. Okay, so we're basically multiplying 3/4 by 1, which just leaves it exactly as it is, and then we're expressing the 1 as 5 divided by 5. Anything divided by itself is 1. And with the 4/5 term, we're going to multiply that by 4 over 4. Because then we see we've got 5 times 3 is 15. We've got 5 times 4 is 20. And then we're adding to that 4 times 4 is 16. And 4 times 5 is 20. So you see we've got the denominators the same now. So the addition then becomes very simple. 15 plus 16 is simply 21/20, which is of course 1 and 1/20. A simple subtraction. We'll do 5 7s minus 3 7s. And that is just simply 5 minus 3 is 2 7s. A more difficult subtraction, we'll do 4/5 minus 3/4. Okay, and we apply the same trick here that we did with the addition when the denominators are different. So we're going to multiply the first fraction by 4 divided by 4. So we're going to have 4 4s are 16. 4 5s are 20, and then we're subtracting that, and we're going to multiply the second fraction by 5 over 5. So 5 3s are 15, 5 4s again are 20, and now we have the same denominators, and so the subtraction is simply 16 minus 15 is 1 over 20. Multiplication of fractions turns out to be very simple, so we'll consider the case of 3/4 times 4/5. We saw in the part 2 theory that this is just 3 times 4 over 4 times 5, which is 12 over 20, and we can divide both of these by 2, so it's 6/10, and we can divide them by 2 again to give us 3/5. 5's a prime number, so that's not going to divide down anymore, and so the answer is 3/5. Dividing fractions. So let's look at 3/4 divided by 4/5. And what we're going to do is we're going to multiply this whole thing by 5/4 over 5/4. So that's just 1. Okay, and again we know from the theory part that this is 5/4 times 3/4 over 5 over 4 times 4 over 5. This is 5 times 3 is 15. 4 4s are 16. And then that's divided by 5 4s are 20. 4 5s are 20. So this is 1. Anything divided by 1 is just left as it is. So the answer is simply 15/16. A much easier way of actually seeing that would be to say that 3/4 divided by 4/5. Well, we remember from the theory that dividing is the same as multiplying by the reciprocal. So this is the same as 3/4 multiplied by the reciprocal 1 over 4 over 5, which is 5 over 4. And then we get straight to the answer, 15/16, once again. Well, I hope that was useful to you. If you are following this review for your own interest, then I hope you enjoyed it. And if you're going to do a GCSE exam, then I hope that I've crystallised and maybe simplified some ideas in your mind about the nature of the subject being examined. But of course, what you now need to do is get lots and lots and lots and lots of practice doing exams. Thanks for watching. Goodbye.